finding absolute maximum and absolute minimum for a problem. So what we have is a function f of x, and that function is defined on a closed interval from a to b. It is very important. The function has to be continuous and the interval has to be closed. We need those two things for the function to have an absolute maximum and an absolute minimum. Right. Again, the function has to be continuous and an interval has to be closed. Right. So the first thing we do is to find the critical points. The critical points is where the derivative equal to 0 or derivative does not exist. But whatever the point we find have to be in the domain. So wherever the point that makes the derivative equal to 0 or derivative does not exist has to be in the domain. Right. So after we found the critical points in the domain, there are three ways to find the absolute maximum or absolute minimum. The first one is to use original function. Oops, sorry. Is to use original function. So pretty much we put everything, all the values, including the boundary a and b. A and b pretty much come from the problem. Those are the boundaries or the endpoints, and then we will have every critical point in between a and b. After that, put in the function, evaluate the function. Whatever the biggest values, the function values, whatever the biggest function values is the absolute maximum, whatever the smallest function values is the absolute minimum. That the first way is to use original function. Now, on a special case where we have exactly one critical point in the domain, and this is crucial, we have to have we have to have exactly one critical point in the domain for it to work. If it is the case, we might use the first derivative test. The first derivative says if the function increasing then decreasing, of course we're going to have the maximum at that point. If we have the minimum, and then if we have the function decreasing and then increasing, of course we will have the minimum at that point. So pretty straightforward. Again, only works if we have exactly one critical point in the domain. Method number 3 only works if we have one critical point in the domain. It says that uh, even though we use the second derivative, we still require the first derivative equal to 0, which means C is a critical point or critical number. Now, if the second derivative is positive, the function concave up, and that point will be the minimum. If the second derivative is negative, the function concave down, and that point is the maximum. And if it is equal to 0, it is inconclusive. Find the absolute maximum and minimum for the function f of x equal to x plus 4 over x on an interval 0 to infinity. First, for an absolute maximum and absolute minimum exists, we have to have two things. First, the function has to be continuous and the interval has to be closed. And in our problem, we have x between 0 and infinity. It is not closed, so we may or may not have an absolute maximum and absolute minimum. Right. So the first thing we do is to find the critical point or critical number. Right. So we just take derivative and the function, and we just rewrite the function f of x equal to x plus 4 over x equal to x. I rewrite like that so it is easier to take derivative. Now we take derivative, it is just a power rule. Derivative of x is 1. Derivative of 4x to negative 1, I will just write 4 negative 1 x to the negative 2, or I can write as 1 minus 4 x to the negative 2, or we can put 1 minus 4 over x squared, and if we multiply x squared top and bottom of 1 x squared divided by x squared, the derivative will be equal to x squared minus 4 over x squared. So that is the first derivative. Of course, any of this is also the first derivative. I just rewrite that differently. Right. Now to find the critical numbers. Critical numbers, let me go back to the note. Critical point or critical number is where the function equal to 0 or the function does not exist. But it has to be in the domain in our problem. Right. So what we do is we're going to let the function equal to 0, I mean the derivative equal to 0 or derivative does not exist. Derivative equal to 0, we have the rational function. That means the top is equal to 0, or derivative does not exist. That means the bottom is 0. Right. So the top equal to 0, that's easy. We just have x squared minus 4 equal to 0. So x squared equal to 4. And we check the square root on both sides. That make sure there's a plus or minus. So it's plus or minus 2. And then when the bottom equal to 0, again, take the square root on both sides. Plus or minus square root of 0, which is still 0. So what we have is 0, 2, and negative 2. Right. Now, very important that all the critical numbers has to be between 0 and infinity. So that is very important. So we said critical number from 0 to infinity. Even though we found negative 2, positive 2, and 0, only one point is actually between 0 and infinity. So we only have one critical number, is x equal to 2. Right. So that the first step is find all the critical numbers in the domain. And we have only one critical number, and that is very important. I go back to this again. Now, in our problem, we have exactly one critical point or one critical number on the domain. In this case, we have a lot of options. We can use any of this method, 1, 2, or 3. method number 3 here, second derivative test, simply because the second derivative is easy to find. If we cannot find the second derivative easily, then we can go to the method 2 or maybe 1. But we will use the method number 3 because the second derivative is relatively easy to find. Right. So the first step is find critical number on 0 to infinity, and we found only one. The next step is finding the absolute maximum and absolute minimum. Right. So most importantly is since there is exactly one critical number on the interval, we use the second derivative test. Right. So second derivative test, of course, we find the second derivative. The first derivative, we can use this, uh, or we can use this. I'm going to use the 1 minus 4x to negative 2 because that's easy to take derivative after that. So first derivative is 1 minus 4x to the negative 2. Right, 1 minus 4x to negative 2. Right, and then we take the second derivative from here. It will be very easy. Derivative of 1 is 0, and then the other one is using the power rule. Give us ax to negative 3 or h over x cubed. All right, so that is the second derivative. And then we just check. We have the point x equal to 2, so we're going to put 2 into the second derivative. So at x equal to 2, the second derivative at 2 is equal to 1, which is positive, which means the function is concave up, and the critical number will be the minimum. So we will say the absolute minimum equal to something at x equal to 2. And because the interval is not close, we don't have the equal sign. Therefore, uh, and we only have one critical number. So the interval is not close. We don't have the endpoints, and we only have one point in the middle. So pretty much we only have one point that can be a maximum or minimum, and it is the absolute minimum. So now problem, we will not have the absolute maximum. So we say no, there is no absolute maximum. Right. The only thing we need to do is just find out what is the values of the function when x equal to 2. So that's very easy. We go back to the function is f of x equal to x plus 4 for x. So when x equal to 2, so that is equal to 4. So the values of the function is equal to 4, and that is the absolute minimum value when x equal to 2, and there is no absolute maximum.